Hello students, welcome to Vyas Edification Kota. In this series of NCERT discussion, we'll continue further with Mathematics class 11th. The chapter that we're dealing with is Sequence and Series, and now is the turn of exercise 9.3. This particular exercise is based on the concepts related to geometric progression and geometric mean in general, related concepts of geometric progression, right? So you should be aware of the concepts, and along with the questions, we'll also revise those concepts with you, right? So continuing further, the first question says, find the 20th and nth terms of the GP this, okay? So if you have a GP like this, GP looks like this, AR square and continuously like this. The nth term will be AR power n minus 1. First term is A, common ratio is R, and the nth term is AR power n minus 1. There's another formula for the sum of n terms, sum of first n terms, and that is A R power n minus 1 upon R minus 1. This is the formula for sum of first n terms where R should not be equal to 1. And there's a special case which comes further when we want to find limit as n tends to infinity. Okay, what do you mean by limit as n tends to infinity? You can call it sum up to infinite terms S infinity. And what is that equal to? A upon R minus, A upon 1 minus R, 1 minus R. This is when modulus of R is less than 1. This is another important result which is useful at times when you are given infinite terms geometric progression, right? In such, you can find sum up till infinite terms if the common ratio is having a magnitude less than 1, right? And this is in general the summation of first n terms of a geometric progression, right? Keeping these in mind is important. In this particular question, we'll just need the starting few concepts, but later on we'll require the other concepts as well up to here. This particular concept, you generally don't find questions in NCERT from this idea. Let's take a look at the first question. Find the 20th and nth terms of the GP. So in the GP, 5 by 2, 5 by 4, 5 by 8, I have first term as 5 by 2. The common ratio can be written as A2 upon A1, which is 5 by 4 upon 5 by 2. What is that equal to? This is 1 by 2. Okay, common ratio has been found. Therefore, A20, the 20th term will be equal to A R power 19. What is that? 5 by 2 into 1 by 2 whole power 19. What does that give me? A20 is required, and that is 5 upon 2 power 19 into 2 is 2 power 20 in the denominator. That is my 20th term. What about the nth term? An will be A R power n minus 1, which is 5 by 2 into 1 by 2 power n minus 1, and from here I can say that An will be 5 upon 2 power n. This will be the value of An. Is that okay? Yes. That's the first complete solution for this first question. In the second question, we have find the 12th term of a GP whose 8th term is this and the common ratio is this. So for knowing a GP completely, we need to know the first term and the common ratio. Here the common ratio is given as 2. Find the 12th term. A12 is question mark, whose 8th term is A8 is 192. This is given, right? So R is given, and for finding A, this another condition is given. I can easily find A with the help of this condition. I can use the values of A and R to get A12 easily, right or not? Yes. So what does this tell me? This tells me, okay, A R power 8 minus 1, which is A R power 7, is equal to 192. A is okay. R is 2. So this is 2 power 7 is this 192. That tells me A will be 192 upon 2 power 7. Now 2 power 7 is 2 power 5, 32 times 2 power 2, which is 4. And 32 cancels with this 192 6 times. This becomes 3 by 2. That tells me, okay, A will be 3 by 2. You already know the value of R and now you have found A, so you know complete GP. A8, as you can see, okay, A8 is already used. What we are asked to find is A12. So let's find A12. A12 will be A R power 11. What does that tell me? A12 will be A, that is 3 by 2 into R power 11, which is 2 power 11. This implies 3 into 2 power 11 upon 2 will be 2 power 10. And what is 2 power 10 equal to? 2 power 10 is 1024. You should remember that. Which powers of 2 should you remember? You should remember 2 power 5, which is 32. And you should remember 2 power 10, which is 1024. If you remember these two, you can find the rest very easily, right? For example, 32 into 2 will be 64, into 2 will be 128, into 2 will be 256, into 2 will be 512, into 2 will be 1024. The numbers you are generally familiar with, but the powers, right? 2 power 10 and 2 power 5, if you know these, then middle numbers can be easily found. What is this equal to? This is 3 into 3072 is what you get. That's the correct answer for this second question over here. In the third question, what do we have? The 5th, 8th and 11th terms of a GP are P, Q and S respectively. Show that Q square is equal to PS. Okay. A5 is equal to P, A8 is equal to Q, A11 is equal to S. That's what the person says, right? Show that Q square is equal to PS. We'll show that. First, let us write A5. This is A R power 4, which is equal to P. This tells me A R power 7 is equal to Q. A R power 10, which is equal to S. This is what it simplifies into. And now, for Q square is equal to PS, can you find the LHS? To prove Q square is equal to PS, LHS will be equal to what? LHS is Q square, which is A R power 7 square. What is that? A square R power 14. What about the RHS? RHS is equal to PS. What is that equal to? P is A R power 4, S is A R power 10, and multiplying these two together, A times A will be A square. R power 4, R power 10 will add up to give you R power 14. Powers will add up and that will give you R power 14. From here and here, therefore you can say that LHS is equal to RHS, and obviously hence proved. That's the complete proof of this third question. Pretty simple? Yes. In the fourth question, it says the fourth term of a GP is square of its second term. Fourth term is square of its second term. So A4 is equal to A2 square. This is given. And the first term is minus 3. A1, which is actually equal to A, is minus 3. Determine its seventh term. A7 is equal to question mark. So just after you write what is given, what is asked, you will realize that, okay, first term is given. Using this, let us find the common ratio and then we'll find A7 easily. Yes? Okay. So what does that tell me? A R power 3 is equal to AR and its square. This is what it tells. From here, I note that A R power 3 will be equal to A square R square. Yes or no? Yes. And A is non-zero, so you can cancel A. R is non-zero, so you can cancel R square. This is R and this will be equal to A. Okay. That's what you note. R is equal to A, which implies that R will be equal to minus 3 as well. R will also be equal to minus 3. This is what you need. Okay. A is minus 3, R is also minus 3, therefore A7. What will be the value of A7? A7 will be A R power 6, which is minus 3 times minus 3 power 6. Okay, this minus 3 looks okay. Minus power 6 will be plus and 3 power 6 will be 729. 729 multiplied by this will be minus 2187, and this is my required answer for this fourth question, as you can see over here. In the fifth question, the person says which term of the following sequences is 128. This is part A of the fifth question. And you can observe that A is equal to 2. Common ratio is this 2 root 2 upon 2, which is square root of 2. Common ratio is square root of 2. Which term an is equal to 128, that is given, n is being asked. Does not look like a very difficult question. You just need one formula. What is that? An will be a r power n minus 1, and let's use that to get the value of n. 128 is equal to 2 times root 2 power n minus 1. What is that? 64 is equal to 2 power n minus 1 by 2. Once you observe this 64 is 2 power 6. So 6 will be equal to n minus 1 by 2, or n minus 1 is 12, and n, the value of n will be 13. You're talking about the 13th term. 128 is the 13th term of this sequence. Is that okay? Yes, that's okay. That's the fifth part A. In part B, it is asked, okay, root 3 root 3, which term of this sequence is 729? Once again, we have a geometric progression whose first term is root 3, common ratio is root 3, right? 3 upon root 3 and all. This is what you have. An is 729. What is that? A r power n minus 1 is 729. Okay, A is root 3. R is also root 3. So this is root 3 times root 3 power n minus 1, which is 729. This is 3 power 6. Let's write it in terms of powers of 3. Okay, this becomes root 3 power n minus 1 will be n. This is root 3 power 12. Is that okay? Yes, please take a look at this carefully. This is root 3 power 12. Therefore, n will be equal to 12. That's my required answer for this particular part B. In part C, we have 1 by 3, 1 by 9, 1 by 27, dot, 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 and 1 by 19683 is the term that you're looking forward to. A is 1 by 3. A is simply 1 by 3. R is 1 by 3 again. A is 1 by 3, R is also 1 by 3. An is 1 upon 19683. Okay, which tells me, okay, this will be A r power n minus 1, which is equal to 1 upon 19683. What is A? That is 1 by 3. R is 1 by 3. So 1 by 3 into 1 by 3 power n minus 1 will be 1 by 3 power n, which is 1 upon 19683. Can you take out some particular factor common from here? Maybe yes. This divides with 3 easily. So this becomes 3 times 6, 5, 6, 1. This is what you get, right? Okay, this is 3 power n is equal to 3 into 6, 5, 6, 1. Okay, one thing you can observe easily, that for 3 power n you have 19683. The last digit of this particular thing is 3. If you take this 3 over here, the last digit will be 1. Okay, and last digit 1 is obtained for example, 3 power 4 is 81. If you take a look at 3 power 4 or 3 power 8 or 3 power 12, the last digit will be 1. So for finding the 6561, for writing the 6561 as power of 3, it is not difficult. You just have to think about 3 power 4, which is 81. Okay, that's not true. 3 power 8 is nothing but 81 square, and what is that? That's same as 6561, yes? That should be 6561. Let's check that. 1 square is 1. 1 into 8 is 8, and 8 plus 8 is 16. 6 and 1 carry 8 is 64 plus 165, yes. So this is nothing but 3 power 8. There's a 3 as well. This becomes 3 power 9, which tells me n is equal to 9. That's my required answer for this simple question. It's pretty simple. Question number 6 says, for what values of x, the numbers this are in GP. Okay. If it is given that 3 numbers are in GP, what kind of a relation do they have? So if A, B, C are in GP, you can say that the common ratio, this B upon A, will be equal to C upon B, or you can also say that B square will be equal to AC. Those are two things which you can be sure of. Okay. So if this three numbers are in GP, therefore minus 2 by 7 into minus 7 by 2 AC will be equal to B square, or you can say that X square will be equal to minus goes 2 goes 7 goes, so this is equal to 1, which tells me X will be equal to plus minus 1. Plus 1 or minus 1, both the answers are correct in this case, and that's my required answer for this question, as you can see over here. Question number 7th. Find the sum to indicated number of terms in each of the geometric progressions in exercises 7 to 10. Sum of each of these, right? Sum to indicated number of terms. Now, once we have AR square dot 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 AR power n minus 1, you have the first term, you have the common ratio, and finding the sum of first n terms is not at all difficult. This is R power n minus 1 upon R minus 1, or I can write it as A times 1 minus R power n upon 1 minus R. Both are correct, yes. You simply multiply with the minus and numerator and denominator, you get this. From here you can reach this anyways, right? So that's true. Both the formulae are correct. In this particular question, what do I observe? For 0.15, comma 0.015, 0.0015, comma dot dot dot, I observe that first term is 0.15. Common ratio is this divided by this, which is 0.01. Sorry, 0.1. That's what you can observe, right? 1 by 10 or 0.1. The number of terms, the person says, okay, n equals 20, and now you're supposed to find sum. So sum up till 20 terms will be A 1 minus R power 20 upon 1 minus R. This is what you need, right? And what is this equal to? A is given. A is 0.15. 1 minus R, which is 0.1 power 20 upon 1 minus 0.1 is what you get, right? This is equal to 1 minus 0.1 will be equal to 0.9. So what you get is 15 upon 90, which is 1 upon 6. This becomes 1 by 6, 1 minus 0.1 power 20. That is your S20 and my required answer in this particular question number 7th, as you can see over here using this formula. Yes. For the 8th question, you are given the geometric progression and you are asked to find the sum up till n terms. So what is given is A is equal to square root of 7, R is equal to square root of 3, Sn is equal to A R power n minus 1 upon R minus 1. Why did I use R power n minus 1 upon R minus 1 here rather than using 1 minus R power n upon 1 minus R? There's no big hi-fi theory about this. Just that this denominator, whenever I see R greater than 1, I want to make this positive over here, and since root 3 is greater than 1, I'll write it as this. In the previous question, it was R was 0.1. So why make this unnecessary negative? Why not modify the formula to make this positive? Because once you make it negative, after that also you'll have to multiply with a minus and make it positive. So therefore, this is root 3 minus 1 now. This A is root 7. This is root 3 power n minus 1 upon root 3 minus 1. This is what I observe, right? But denominator cannot be irrational, cannot be left irrational. So what do we need to do? We need to rationalize this. So let's multiply with root 3 plus 1 over root 3 plus 1. We don't generally prefer leaving irrational terms in the denominator, right? Otherwise, this is sufficient. That's the final answer for this question and we are good to go, right? But if you want to do this, what do we get? So root 7 times root 3 is root 21 plus root 7. So root 21 plus root 7 upon 3 minus 1. Root 3 square is 3 minus 1, which is 2. And then you have root 3 power n minus 1, and that is my correct answer for this question, as you can see over here. In the ninth question, I have 1 comma minus a comma a square comma minus a power 3 up till n terms. Okay, so first term is 1 common ratio. As per the formula, the common ratio is minus a. Not this a, mind you, this is minus a. And we are asked to find the sum up till n terms. Sn will be equal to first term common ratio 1 minus common ratio power number of terms upon 1 minus common ratio. This is what you need, right? What is this equal to? A is not equal to minus 1, okay. 1 minus a power n upon 1 plus a is the answer for this question, as you can see over here. In the 10th question, we are given x power 3, x power 5, x power 7, dot 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 up till n terms, and we are supposed to find the sum. So first term is x power 3, common ratio will be x square, and sum up till n terms will be a r power n minus 1 upon r minus 1. What is a? A is x power 3. This is r power n, which is x square power n, that becomes x power 2n minus 1 upon x square minus 1. That's my answer for this 10th question, as you can see over here. In the 11th question, the person says evaluate this summation 2 plus 3 power k. How will we do that? So summation k is equal to 1 to 11, 2 plus 3 power k. If you observe, this 2 is independent of k. This 3 power k is dependent on k. I can write this summation as summation of 2 plus summation of 3 power k, where k goes from 1 to 11, k goes from 1 to 11. Okay. This implies that 2 plus 2 plus 2 up till this will have 11 times 2. 11 terms of 2. Plus, what would this other sequence look like? Series look like? This will be 3 power 1, 3 power 2, dot 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 up till 3 power 11. And this is a GP. As if you can observe, this is a GP having 11 terms. Okay, so this is 11 times 2 plus, what is this? First term 3, common ratio 3, power number of terms minus 1 upon common ratio minus 1 is what you need over here. This becomes 22, and this is 3 by 2. In the bracket you have 3 power 11 minus 1. That looks like the final solution, right? That's the complete solution and final answer for this question, number 11th, as you can see over here. In question number 12th, we have sum of first 3 terms of a GP is 39 upon 10 and the product is 1. Find the common ratio and the terms. Okay. Product of the terms is given, yes. So which 3 terms will you consider, right? Now, the first 3 terms I can choose. Let AR square be the first 3 terms. That's one of the choice. That's one choice. Why am I calling it one choice? Because I have another choice. Whenever you are given terms in GP and product is given, and their product is given, then you can maybe think in other terms as well. That is, you can maybe consider A upon R, AR as the 3 numbers. This is another possibility. This is another possibility which works wonders, right? What happens in this case, the product, as you can see, is A, R gets cancelled, A power 3 is the product, and that product is given to be 1. So you directly get the value of A, that is one of the variables solved, single step. For solving the other variable, you should be given another condition, and that's this 39 upon 10 over there, right? So that's one of the standard ways of considering the 3 numbers when they are in GP and the product is given. Why am I specifying that the product is given? Because only the product will eliminate R, right? Okay, so should we choose these or should we choose those numbers? Okay, we can always go ahead with that one, right? Because A is 1, you can clearly observe that will be the case. In this particular case, maybe we'll face certain amount of difficulties in calculations, but then let's go the hard way. Why? What's the harm in that, right? You can always practice on your desk using these few numbers, but on the board, let me solve this with the help of AR and AR square. Slightly complicated, but then we'll be able to manage, I suppose. Sum of the first three terms of a GP is 39 upon 10. So it is given that A plus AR square is 39 upon 10. Product is 1. What does that tell me? AR square is equal to 1. That tells me A power 3, R power 3 is equal to 1. Or that tells me that AR is equal to 1. Right? Cube root of 1 is 1. Find the common ratio and the terms. That's the question in front of us. Okay. So first, let's focus on finding the common ratio. A can be replaced with 1 upon R. So this becomes 1 upon R plus 1 plus R is equal to 39 upon 10. Now do you observe that had you started from here, you would have obtained A equals 1, and after you put A equals 1, this is 1 by R, 1 and R only. You would have reached exactly this stage, right? Which looks pretty easy, right? Such calculations, basically you directly get the value of A. Mind you, A is not the first term in this case. A is the first term here. Here the first term will be A by R. Common ratio is still R, but the first term is A by R, right? Take care of that. Now, how do we attempt this? So let's multiply throughout with R times 10. R times 10, those are the two numbers in denominator. So 10R upon R will be 10, plus this is 10R, plus this is 10R square, and this is 39R. That tells me, okay, 10R square minus 29R plus 10 is equal to 0. That's what you get, right? Taking that 39R from the left hand side into the right hand side. And now 10 into 10 is 100. 100 can be broken down factorized to give you some 29. 25 into 4 is okay? Yes, 25 into 4 is okay. So this is 10R square minus 25R minus 4R plus 10 is equal to 0. Can we take out something common from here? Yes, 5R will come out common, and what remains is 2R minus 5. 5R came out common from there, 2R minus 5 remains, at minus 2 will come out common from here. This is what remains, okay? Therefore, R will be equal to 5 by 2, or R is equal to, from here, 2 by 5. This is what you get, right? Either this is 0 or this is 0, since the product is 0, this or this. Okay, R is 5 by 2 or 2 by 5. We have found the common ratio, either this or this is the common ratio. And the terms, depending upon the value of R, we can get this. Depending upon the value of A, since AR is equal to 1, this tells me A will be equal to 1 upon R, which is 2 upon 5. Or A is equal to 1 upon R, which is 5 upon 2. Okay. So terms in this case will be A, 2 by 5, AR, which is 1, AR square, which is again multiplied by 5 by 2. This is what you get, right? Terms in this case will be 5 by 2, which is the first term. Multiply by 2 by 5, this will be 1, and multiply by 2 by 5, this will be 2 by 5. Either this or this is my final answer for this question. Common ratio, if this is the common ratio, these are the terms. If this is the common ratio, these are the terms that you have for this geometric progression. That's a complete solution for this 12th question, as you can see over here. In 13th question, what do we have? How many terms of GP, 3, 3 square, 3 power 3, dot, 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 are needed to give sum 120? So A is 3, R is also 3, Sn is 120. How many terms? That implies that n is a question mark, right? Okay. Sn is 120. What does that tell me? Sn is generally A R power n minus 1 upon R minus 1. That tells me 120 will be equal to A 3 power n minus 1 upon 3 minus 1, which is 2. Okay. 2 into 120 is 240. Divided by 3 will be 80. 80 is equal to 3 power n minus 1. That tells me 3 power n is equal to 81, which is 3 power 4, and that further tells me n will be equal to 4. That's my required answer for this question, as you can see over here. Pretty simple question, yes. Question number 14 says, find the sum of first 3 terms of a GP is 16 and the sum of the next 3 terms is 128. Gee, interesting. Let's take a look at this one. Determine the first term, the common ratio, and the sum to n terms of the GP. Okay, we are supposed to find everything. First term, common ratio, and sum to n terms of the GP. So for finding this, we can first find A and R, and then we can be done. Sum of first 3 terms of GP is 16. So A plus AR plus AR square is equal to 16. This is given. What else is given? Sum of the next 3 terms, mind you, next 3 terms, that is after AR square you will have AR power 3, AR power 4, AR power 5, and that sum is given as 128. Okay, that's not an issue, right? So this is equation number 1 and this is equation number 2, or I would like to modify this a bit. Can I take out R power 3 common? This becomes A plus AR plus AR square, which is equal to 128. This is equation number 2. Let's call this equation number 2. Now if you see, you have the value of A plus AR square, which can be substituted over here. Using equation 1, this gives me R power 3 times 16 is equal to 128. Is it not? Yes. This is 2 power 4, this is 2 power 7. That tells me R power 3 will be equal to 8. Or that tells me R will be equal to 2. Since this is power 3, there is no need to add a plus or minus. We don't have to think of this. R is equal to 2 is the only value. Okay. And once you obtain R is equal to 2, can you find A easily from here? Yes. Therefore, equation 1 gives me A 1 plus R square is equal to 16. A is okay. 1 plus 2 plus 4 is equal to 16, which tells me A is equal to 16 upon 7. This is what you know. A equals 16 upon 7. Is that okay? Yes. So we have found A, we have found R, and what else do we need? We need sum to n terms, and what is that? A R power n minus 1 upon R minus 1. That tells me Sn will be equal to 16 upon 7, 2 power n minus 1 upon 2 minus 1. This is what you have. Sn is equal to 16 upon 7, 2 power n minus 1. That's the required answer for this question, as you can see over here. Question number 15 says, given a GP with A is equal to 729 and 7th term 64, determine S7. Okay, GP whose A is equal to 729 and 7th term A7 is equal to 64, S7 is equal to question mark. Since A is given, with the help of A7, I can find the value of R. Yes, A7 is AR power 6, which is 64, and this A is 729 times R power 6, which is 64 to power 6. This 729 is also 3 power 6, right? So R power 6 is 2 upon 3 power 6. Now be very careful over here. If you take the square root throughout, what you will get? R power 3 will be equal to 2 by 3 power 3 or minus 2 by 3 power 3, right? And similarly, R will be equal to 2 by 3 or minus 2 by 3. Had this been an odd power, you would have obtained R is equal to 2 by 3 only. But in case of power 2, 4, 6, 8, you will obtain plus or minus both answers as correct. So R can be either 2 by 3 or minus 2 by 3. What do we note from here? That A is same, right? R, there are 2 possibilities, and correspondingly we will get 2 different values of S7, right? So S7 for A is equal to 7 to 9 and R is equal to 2 by 3. S7 is equal to A 1 minus R power n upon 1 minus R. What is that equal to? 7 to 9, 1 minus 2 by 3 power 7. S7 will be R power 7 over here. Let's write R power 7 only. upon 1 minus 2 by 3. This is 1 by 3 over here. This 729, what is 729 actually equal to? 729 is nothing but 3 power 6. Let's write it as 3 power 6, right? In the bracket you have 3 power 6 minus 3 power 7. 2 power 7 upon 3 power 7, let's take the LCM, this becomes 3 power 7, 2 power 7 upon 3 power 7. In the denominator you have 1 by 3 which rises above, this is denominator's denominator which is 3 over here. 3 into 3 power 6 is 3 power 7 which gets cancelled, and I get 3 power 7 which is 729 into 3, and that is 2187, minus 2 power 7 which is 128, and that tells me S7 is equal to 20659. This is what you get. S7 is 2059. That's one possible answer. You can have another possible answer. For A is equal to 729, comma R is equal to minus 2 by 3, you get S7 is equal to 729, 1 minus 2 by 3 power 7 upon 1 minus 2 by 3. This is what you get. 729 is 3 power 6. This is minus, so minus of minus will become a plus. 3 power 7 plus 2 power 7 over here upon 3 power 7 over here. What else? This is 1 plus 2 by 3 which is 5 by 3. 5 by 3 is what you get, right? 3 power 6 into 3, 3 power 7 will get cancelled as you had over there. What is 3 power 7 plus 2 power 7? 3 power 7 plus 2 power 7 will be sum of these two. 8 plus 7 is 15. 2 plus 8 is 10 plus 1, 11. 1 carried. 21 plus 1 is 22. This becomes 2315 upon 5. And that tells me S7 is equal to 463. So the correct answer is this or this. 2059 or 463. Both are correct depending upon the values of R over here, right? You can take a look at this complete solution. The two different answers are obtained depending upon the values of R that you consider, right? That's all in this 15th question, as you can see over here. For 16th question, what do we have? Find a GP for which sum of the first two terms is minus 4 and the fifth term is 4 times the third term, Find a GP for which the sum of first two terms is minus 4. A plus AR is equal to minus 4 and the fifth term is 4 times the third term. This is also given, right? So you are supposed to find a GP means you should be aware of A and R to find the GP. This tells me A R power 4 is equal to 4A R square. A will get cancelled, R square will be equal to 4, which tells me R will be equal to 2 or minus 2. There are two possibilities for R, right? And depending upon the two possibilities, I can get two different values of A. So R is equal to 2 or R is equal to minus 2. Let's solve them like this. A plus AR, therefore this equation 1 gives A plus AR, which is 2A. 3A is equal to minus 4, which tells me A will be equal to minus 4 by 3. Here 1 tells me A minus 2A, which is minus A is equal to minus 4. That tells me A will be equal to 4. So for R is equal to 2, A equals minus 4. We are supposed to find the GP, so therefore GP formed will be minus 4 by 3, comma, you multiply with a 2, minus 8 by 3. You multiply with a 2, this becomes minus 16 by 3, dot dot dot. This is what you get, right? Or the other GP will be first term 4 multiplied with minus 2, multiplied with minus 2, and so on and so forth. This is the other GP that you'll get, right? Is that okay? Yes, that's what you have in the 16th question over here. For question number 17th, what does this question say? If 4th, 10th and 16th term of a GP are x, y and z respectively, prove that x, y, z are in GP. So A4 is x, A10 is y, A16 is z. This is what the person says, right? A16 is z. Prove that XYZ are in GP. What does this tell me? This tells me A r power 3 is equal to X, A r power 9 is equal to Y, A r power 15 is equal to Z. We'll write Z like this, right? With a cross. Okay. And XYZ are in GP. If three numbers are in GP, if X, Y, Z are in GP, this implies that Y square will be equal to XZ, and this double implies actually. So we can say if XYZ are in GP, then this, if this is true, then XYZ will be in GP. Both the conditions are true. Okay. So can you say that you can easily find XZ and you can check whether this is equal to Y square or not. So XZ is equal to what? XZ is A r power 3, A r power 15, which is A square r power 18, which is A r power 9 square. This is nothing but Y square. That tells me, okay, XZ is equal to Y square, which can be rearranged to this Z by Y is equal to Y upon X, and obviously this or this tells us that X, Y, Z are in GP, and this is what we wanted to prove, right? That's a complete proof for this particular question number 17th, as you can see over here. In question number 18th, what do we see? Find the sum to n terms of the sequence this. Okay, looks like a very interesting sequence. S, n terms, 8 plus 88 plus 888 plus dot dot dot. So what we'll try to do over here is we'll try to create some kind of a geometric progression somehow. And for creating a geometric progression, what do we need to do? First, let us take out 8 common from here. So this will be left with 1, 11, 1, 1, 1 and 1, 1, 1, 1. That will not take us anywhere. So multiply with the 9 and divide with the 9. This is a standard step. Whenever you get this kind of a series, take out this 8 common, you get 1, 11 and so and so. You multiply with the 9, divide with the 9. This becomes a 9 now. This becomes 99 now. This is what you have, right? Okay. And this 9, 8 by 9 is okay. This 9 can now be written as 10 minus 1. 99 is 100 minus 1, which is 10 square minus 1. 999 is 10 power 3 minus 1, and so on. This is what you get, right? Now you see these terms will form a geometric progression. 1, 1, 1 will come n times, right? So 8 by 9 is okay, that's not an issue. In the bracket, what do you get? We see 10 plus 10 square plus 10 power 3 plus dot 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 up till n terms, and minus 1, 1, 1, 1, 1 n times is n. This is what you have. Is that okay? Yes. This is a geometric progression. And this tells me, okay, Sn will be equal to 8 by 9 is okay in the bracket. This is a geometric progression having n terms. First term 10 power into common ratio power number of terms minus 1 upon this, and minus n is also there. This is what you have. Okay, so this is a 9. Let's bring this 8 by 9 inside. This becomes 80 by 9 into 9 is 81. 10 power n minus 1 minus 8 n by 9. That's my correct answer for this question. Okay, and do you see that this 8 comes into rest? This bracket remains same even if we had 7, 77, 777. Only this 8 will be changed to 7. If we had 5, 55, 555, 5555. So this 8 will be replaced with 5. That's the only modification. So this 80 will become whatever, and this 8 will be changed. Rest everything will remain same in all of those questions as well, if you have some other sequence as well, right? That's the complete solution and the final answer for this 18th question, as you can see over here. Question number 19 says, find the sum of the products. So the products of the corresponding terms of the sequences 2, 4, 8, 16, 32 and 1, 28, 32, 8, 2, 1 by 2. corresponding products, that's what we are interested in, yes. So 2, 4, 2, 4, 8, 16, 32, that's the sequence. It contains 5 terms. This is geometric progression. Then you have 128, 32, 8, 2, 1 by 2. This is also a geometric progression. Can you see that? Yes. Common ratio is 1 by 4. The common ratio here is 2. R1 is 2, R2 is 1 by 4. And if you multiply the corresponding terms, what do you get? You get 256, you get 128, then you get 64, then you get 32, and you get 16. And this is also a geometric progression R having common ratio 1 by 2, which is simply the product of these two. Don't you think so? Yes. That's what we have, right? So finding the sum is possible if you directly add these few terms, or you can use ideas of geometric progression to find this sum of first 5 terms, where the first term is 256, common ratio is 1 by 2. So sum S5 will be first term 1 minus common ratio raised to power number of terms upon 1 minus common ratio. This is 1 by 2. It goes up, this becomes a 5, 1, 2, and you have 1 minus 1 upon 2 power 5. What is that? This is 2 power 9. This is 32. It's 2 power 5, right? This here is 2 power 5, which is actually 32. So this becomes 2 power 9 into 31 upon 2 power 5. Now 2 power 5, 2 power 9 will be 16. 2 power 4 is 16. 16 times 31 is what we are interested in. Now 16 times 1 is 6, and 16 times 3 is 48, plus 1 will be, 16 times 1 is 6, plus 1 carry. 16 times 3 is 48, 48 plus 1 is 49. 4, 9, 6 is what we seem to get, right? This looks like the final answer. Let's check the calculation once. Right, we can directly find the sum as well. Okay. And if we directly find the sum, what do we get? This is 80. This here is 160, right? So this becomes 240. 240 and 256 is 4, 25 and 24. 25, 24, 24 is 48, 496 is what you get, right? 496, right? So that's the complete sum of this. So what do we identify? The important thing to identify over here is if you multiply corresponding terms of two GPs, the resulting sequence is also a geometric progression, and the common ratio is the product of R1 and R2 over here, right? That's what we have done, and this is how we can solve this 19th question. In question number 20, we have show that the products of the corresponding terms of the sequences. Okay, now this is a question based on, I think, concepts related to previous question, but then let's take a look at this. Sequences AR square, dot dot dot, AR power n minus 1. Then you have capital AR square, comma, dot dot dot, capital AR power n minus 1. Products of the corresponding terms of the sequences this form a GP and find its common ratio. Simple, right? So this is A into A, comma, this is A, R, this is A, R square, and correspondingly you have A, R power n minus 1. Do you observe that yes, this is a geometric progression when you multiply these two terms, and the common ratio, can you observe that first term is AA, common ratio is this RR, right? Common ratio is this. That's the correct answer for this question over here. Question number 21 says, find 4 numbers forming a geometric progression in which the third term is greater than the first term by 9. 4 numbers forming a geometric progression, third term is greater than the first term. Okay, 4 numbers forming a geometric progression. Let's see, AR square, AR power 3. Let this are the 4 numbers forming a geometric progression, right? Third term is greater than the first term. Third term is greater than the first term by 9. And the second term is greater than the fourth term by 18. That's what is given, right? That's given in the question. Okay. So this is one equation in terms of A and R. You can take out A common, you are left with R square minus 1, which is equal to 9. Again, you can take out AR common, you are left with 1 minus R square, and which is equal to 18 over here. From these two equations, do you see that A times R square minus 1 a times r square minus 1 with a minus, this is minus r, into a times r square minus 1, 9 will be equal to 18, and that tells me r will be equal to minus 2 for this. That's the first thing that you observe, right? Okay, this implies this, r equals minus 2. Once you get r equals minus 2, therefore a times minus 2 square, which is 4 minus 1 is equal to 9. That tells me a will be equal to 3. So have you found a? Yes. Have you found r? Yes. Can we easily note the numbers? We can find the 4 numbers, right? Numbers will be ar square. What is that? Multiply with minus 2, this becomes a 12. Multiply with minus 2, this becomes a minus 24. You can check the condition as well, that second minus first is 9, third minus first is 9, and second minus fourth is this 18, right? That's the answer for this question number 21, as you can see over here. Question number 22 says, if the pth, qth and rth terms of a GP are A, B and C respectively, prove that this is equal to 1. Pth, qth terms, rth terms of a GP. So pth term, that implies that AP pth term is equal to A, qth term is equal to B, and rth term is equal to C. Okay, that tells me pth term of a geometric progression. Let the geometric progression be capital A, capital AR, and so and so. So if that is the case, capital A, capital R power P minus 1 will be equal to A R Q minus 1 will be equal to B, A R R minus 1 will be equal to C. This is what you can observe. Now, A power Q minus R is what we are interested in, right? Let's focus on finding A power Q minus R. A power Q minus R will be capital A power Q minus R into capital R power P minus 1 times Q minus R, P times Q minus R, and minus of Q minus R. This is what you will get, right? What about B power R minus P? This is equal to A power R minus P times R power Q times R minus P minus R minus P. This is what you get, right? And C power P minus Q is equal to A power P minus Q times R power R times Q minus, P minus Q minus of P minus Q, right? P minus Q times R minus 1 is this. And now, if I multiply these three, this will be A power Q minus R into B power R minus P into C power P minus Q, and that is A power, multiplying these will add the powers, right? Powers of A. So Q minus R plus R minus P plus P minus Q will be A power 0 actually, right? Into R power, what do we have? PQ minus PR, QR minus PQ. PQ and PQ will get cancelled. PR with a minus, PR with a plus will cancel. QR with a minus and QR will plus will cancel. So R power 0. But what about these terms? Okay, Q minus R, R minus P, P minus Q will again be 0. So A power 0, R power 0, this is simply 1. And this is the complete proof. Yes, this product is equal to 1. That's what we wanted to prove, and that's what we have proved over here. Simple question? Yes, pretty simple question. Question number 23 says, if the first and the nth term of a GP are A and B respectively, and P is the product of n terms, prove that this. First term and the nth term of a GP are A and B. Okay, so GP. P is the product of n terms. Let's talk about product. P will be equal to A times AR times AR square dot dot dot, and second last term will be AR power n minus 1. A term before that will be AR power n minus 2. Yes, do you observe that? Yes. Also, it is known that B is equal to AR power n minus 1. This is something which is known, right? So can I write the same product, or P is also equal to what? Can I write the same product in another way? How is that? So I want to write this as B first of all, yes. And I want to interchange the order, reverse the order basically. So this is also equal to B, yes. And what is this? This is b upon r, right? The next term will be b upon r square. And correspondingly, when you reach at this stage, that will be, the last term will be b upon r power n minus 1, that is a. And here, obviously, you are dividing with r throughout, so this term will be b upon r power n minus 2. Yes or no? Take a look at this particular series carefully. And what do we intend to do after this? Nothing much. We just want to multiply them together. P square will be AB over here. AR upon BR is again AB over here. AR square B upon R square is AB over here. Dot dot dot. This is again AB and AB again. How many terms do you think are there? There were total n terms. Yes, this is n terms. N product. This is what you have. And this tells me, okay, P square will be equal to AB power n. That's what we can note, and that's the proof that we wanted. That's the complete proof of this particular result, right? You can follow another approach. What is that? You can have AR square, AR power this, and write this product alternatively. You can follow directly this, that P will be equal to AAA power n, R power 1, 2, 3 up till n minus 1. You will need the sum of first n minus 1 natural numbers. And what is that? That is n minus 1 into n by 2. And if you find P square, this will be equal to A power n times 2. So A power 2, R power n minus 1, and you have squared, right? This 2 will go away. Power n will come outside. This is what you get, and this is nothing but B times A. So this becomes AB power n. That's alternative approach, and hence proved. Using this approach, you can also prove this one, right? You can also prove using this approach. That's the final result, and this is what we have proved first, right? So you have seen two methods, but that's the complete solution of this question over here. Question number 24 says, show that the ratio of the sum of first n terms of a GP to the sum of terms from n plus 1th to 2nth term is 1 upon r power n. Now how will we deal with this? Let's write the terms first of all. Ratio of sum of the first n terms. So first n terms will be AR square, and so on up till AR power n minus 1. We are also interested in next few terms to the sum of terms from n plus 1th. This is the nth term. N plus 1th term will be this AR power n. Then you will have AR power n plus 1. And so on up till 2nth term. AR power 2n minus 1 is this term, right? And now the person says ratio of the sum of this and this is 1 upon r power n. That's what we want to prove. So ratio, the required ratio is actually equal to A plus AR plus dot 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 up till AR power n minus 1. In the denominator you have first term as AR power n, then you have AR power n plus 1, and so on up till AR power 2n minus 1. Observe these two expressions carefully, and do you see that if the numerator remains as it is, and in the denominator if I take out r power n common, what do I get? A plus AR plus dot 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 plus AR power n minus 1. Do you see this? Yes. R power 2n minus 1 is r power n minus 1 plus n, right? This is what you have. And if you observe carefully, this becomes equal to, these two terms are exactly same. This is 1 upon r power n, which is what we wanted to prove. Yes or no? Yes. That's the complete proof of this question, which is very simple. In the 25th question, what do we have? If A, B, C, D, R and GP show that this expression is equal to this expression. Yes, we can handle that. A, B, C, D in GP, let B is equal to AR, C is equal to AR square, D is equal to AR power 3. We can take these terms, right? LHS, what is left hand side equal to? Now left hand side is A square plus B square plus C square. The right hand side is, there's another term in the left hand side, this. A square is okay. This is A square R square and this is A square R power 4. What is this? This is A square R square. This is A square R power 4. This is A square R power 6. This is what you have. Yes? D is A R power 3. I can maybe take out an A square common from here. This becomes 1 plus R square plus R power 4. I can take out A square R square common from here. What remains is 1 plus R square plus R power 4. Now observe these two expressions carefully. This and this are exactly same, right? So square of this along with A square R square. So what you'll get is A square R square along with 1 plus R square plus R power 4 and its square. So combining these two, R square plus R power 4, what I want to write it as this complete square. Please observe 1 plus R square plus R power 4 square is already there. A power 4 and R square are present over here. That's what I want to write it as. Now, which tells me LHS will be further equal to what? This will be further equal to square of something. And what is that something? Let's multiply this A square R inside. So what do you have? A square R plus A square R power 3 plus A square R power 5. And I can write A square R as A into AR, this as AR into AR square, this as AR square into AR power 3. Yes or no? Yes. A square R can be split as this, A square R cube is this, A square R power 5 is this. Yes, and now I can replace them back. A times AR. AR is nothing but B. AR is B, AR square is C. AR square is C, AR power 3 is D. This is equal to this square, which is my RHS. And that's the complete proof of this one. Yes, that's the complete proof of this 25th question, as you can see over here. Question number 26 says, insert two numbers between 3 and 81 so that the resulting sequence is a GP. Insert two numbers, okay. So 3, comma, G1, G2, comma, 81 is in R and GP, is a GP, right? This is what we are interested in. We are interested in G1 and G2. So if you observe multiplying by R and multiplying by R will give me this. So 81 is actually 3 times R power 3. This is what it will have, right? Number of terms minus 1, that is 4 minus 1, which is 3. That tells me R power 3 will be 27, which is 3 power 3, and which further tells me R will be simply 3. Once you have R, therefore G1 will be 3R, which is 9. G2 will be 3R square, which is 27. So therefore two numbers are 9 and 27. The two numbers that are inserted are 9 and 27 as shown over here. Question number 27 says you have find the value of n so that this particular expression may be the geometric mean between A and B. How will we handle this? A power n plus 1 plus B power n plus 1 upon A power n plus B power n is the geometric mean between A and B. What is the geometric mean between A and B? That's square root of AB, right? And now we are supposed to find the values of n for this particular case. How will we handle this one? Let's take a look at this. We'll cross multiply, right? A power n plus 1 plus B power n plus 1 is equal to A power n square root of A square root of B plus B power n square root of A square root of B. And now let's bring everything on the left hand side and take out something common. For example, A power n root A, if this comes over here, A power n will come out common, okay. Root A will also come out. This is A power n into A, right? This is A power n into root A. Root A will come out common, and what will remain is root A minus root B. This is what will remain. Plus, if B power n and this B power n comes out common, there's a B remaining, there's a root B. Root B will also come out common. Root B will remain from here, and root A with a minus will remain from here. This equals, this minus this equals 0, right? That's the expression that you have on rearranging the whole expression. Now, if you observe carefully, root A minus root B can come out common. This would be leaving an extra minus. So, root A minus root B times a power n, a power root 1 by 2, that is a power n plus 1 by 2. This is what you have. Root a minus root b comes out common. B power n plus 1 by 2 is what I have. And root a minus root b, if it comes out common, there will be extra minus remaining over here. This product equals 0. So that tells me either root a will be equal to root b, or a power n plus 1 by 2 will be equal to b power n plus 1 by 2. That tells me either a is equal to b or n plus 1 by 2 is equal to 0. So either a will be equal to b or n is equal to minus 1 by 2. If a is not equal to b, then the correct value is n equals minus half, and that is what we are looking forward to. Right, find the value of n. The correct value of n is minus 1 by 2. That's all in this 27th question, as you can see over here. Question number 28 says the sum of two numbers is 6 times their geometric mean. Okay. Let a comma b are the two numbers. Okay. Sum of two numbers a plus b is equal to 6 times the geometric mean, which is square root of ab. Show that the numbers are in the ratio. So we are interested in ratio a upon b. Okay, for that, let's divide throughout by b. Yes, this becomes a by b plus 1 is equal to 6 square root of a by b. And now let square root of a by b is equal to t for that matter. And that tells me, okay, this becomes t square minus 6t plus 1 equals 0. I can easily find the value of t by quadratic formula. Minus b plus minus under root of b square minus 4ac upon, this is upon 2a. This is what you have, right? Okay. T, what is t? T is square root of ab, square root of a upon b. This is equal to 36 minus 4 is 32, which is 4 root 2. 4 root 2 divided by 2, this becomes 3 plus or minus 2 root 2. Okay. This is square root of a by b, and if I need a upon b, what will I do? I'll square this, right? That's not a difficult thing, okay? So a upon b will be 3 plus or minus 2 root 2 and its square is what I observe. Is that okay? Yes, that looks pretty much okay. But the person is asking something else. Show that the numbers are in the ratio this. Ratio is given. Okay, so now is this particular thing equal to that also? Let's take a look at this. This is equal to, let's say, in the numerator I need 3 plus, I'll choose first one, that is 3 plus 2 root 2 square. So what I'll do is, let us take this, or 3 minus 2 root 2 square this, right? Let's take them like this or this. This expression is 3 plus 2 root 2 into 3 plus 2 root 2, which is okay. 3 plus 2 root 2, let us write it as square. What I want to do is I simply want to rationalize. What do I want to do? I simply want to multiply with 3 minus 2 root 2 and divide with 3 minus 2 root 2 over here. And what does this give me? This gives me, okay, 3 plus 2 root 2, one term remains as it is. The next term is 3 plus 2 root 2 and you multiply with 3 minus 2 root 2. What's that? A plus b, a minus b becomes a square minus b square. That's 3 square, 9 minus 2 root 2 square, 8, which is simply 1 in the numerator, divided by 3 minus 2 root 2, which is equal to this 3 plus 2 root 2 upon 3 minus 2 root 2, and that's the required proof. But then you would ask, sir, what happens to this one? Nothing much. Just that since we are asked the ratio, show that the numbers are in the ratio this, if a is greater than b, then this is the ratio. If a is less than b, then this will be the ratio, and which will be equal to, once again, you multiply and divide with 3 plus 2 root 2, and what you get is this particular ratio. On multiplying and dividing by 2, this is what you get. Either this or this particular ratio is obtained over here. Either this or this is obtained, depending upon whether a is greater than b or less than b. That's what you have, right? So this and this are nothing but the reciprocal of each other, right? Which is okay. As far as ratio is asked, this can be the ratio or this can be the ratio. Person says, okay, this is the ratio, which is okay for us. Right. So that's the complete solution for this 28th question, as you can see over here. Question number 29 says, if A and G be arithmetic mean and geometric mean respectively between two positive numbers, prove that the numbers are this and this. Okay. Let A comma B be the two numbers. Arithmetic mean A, therefore A will be A plus B by 2. G will be square root of AB. And we are supposed to find the numbers in terms of A and G. Okay. So let's begin. Here we have a relation A plus B is equal to 2A and AB is equal to G square. Let's eliminate one of the numbers A or B and find the other. What do we have? B. So A plus B is simply G square upon A is equal to 2A. And from here I observe this is A square minus 2AA plus G square is equal to 0. This is a quadratic in small a. A is equal to minus B plus minus under root of B square minus 4 into A into C upon 2 into A. This is what you obtain. And that tells me A will be equal to A, 2 goes away, 4 will come out common, and A plus under root of A square minus G square, which is A plus G, A minus G. A will be either this or the minus one, A minus under root of A plus G, A minus G. Either this or this value. If A is the first one, then what will B be equal to? This tells me B will be equal to, you can observe 2A minus A is the value of B. So 2A minus A will be A, and this will be minus under root of A plus G, A minus G, or in this case 2A minus that value will be 2A minus this capital A will be A, and minus or minus will become plus, the same expression A plus G, A minus G in the bracket. This is what you obtain. So you can observe the numbers will be A plus or minus this expression or A minus or plus this expression, which is what we want to prove, right? Which we wanted to prove. So numbers, therefore numbers will be A plus or minus square root of A plus G, A minus G, hence proved. That's the complete solution for this 29th question, as you can see over here. For question number 30, what do we have? The number of bacteria in a certain culture doubles every hour. Okay. If there were 30 bacteria present in the culture originally, how many bacteria will be present at the end of second hour, fourth hour and nth hour? Okay. Doubles every hour if there were 30 bacteria present initially. So A was 30 R. Since the number is doubling, the common ratio is 2. That's what we have. The sequence, the series that will obtain is 30. Sequence will be 30, 60, 120, comma, so and so. How many bacteria will be present at the end of second hour? Okay, every hour. So this is initially A0, what you can call. After first hour, the bacteria number will double. Okay, after second hour, the bacteria number will reach this stage, right? So after first hour, this is what you have. As the person says, present in the culture only, how many bacteria will be present at the end of second hour, fourth hour and nth hour? Let's focus on that. This is A0. After first hour, this is what you have. After second hour, this is what you have, right? After first hour, doubles. After second hour, doubles. And so on and so forth. So using this particular relation, can you see that A0 is simply 30. A1 is 30 into 2. A2 is 30 into 2 square, and similarly you will have AN will be 30 into 2 power n after nth hour. That's after nth hour. Now this is a relation. Now let's read the question what is being asked over here. How many bacteria will be present at the end of second hour? Okay, at end of second hour, number of bacteria will be equal to number of bacteria at end of second hour will be equal to this 30 into 2 square, which is 120. At the end of fourth hour will be equal to 30 into 2 power 4. What is that? 2 power 4 is 16. 16 times 3 is 48. This is 480. At the end of nth hour will be 30 into 2 power n. This is what you have, and this are my answers for this question number 30, as you can see over here. Question number 31 says, what will rupees 500 amount to in 10 years after its deposit in a bank which pays annual interest rate of 10% compounded annually? This is a simple principal interest and compound interest question, and we can easily find that, right? So amount will be equal to what? What will be rupees 500? What will rupees 500? So rupees 500 amount to in 10 years after its deposit in a bank which pays annual interest rate of 10% compounded annually. So this amount becomes 1 plus, you add 10% to this, that means 10% is 0.1. So you multiply this with 0.1, 1 plus 1.1, and that gives you the amount after 1 year, right? So simply amount after 10 years will be multiply this 10 times. That's what you'll get. That's the required amount. And if you recall, the formula for amount using compound interest says, okay, principal times 1 plus r upon 100 raised to what number of times it is compounded, right? That's what we have, and that's the same thing which we get. This is 500 times 1.1 raised to power 10. That's my required answer for this question, which is pretty simple, right? There's nothing difficult in this, I suppose. And if you want, we can just check using first few terms. If this is 500 amount is there initially, this is initial amount. Initial would be called, let us call this A1, A0 for that matter. At the end of 1 year, what will happen? You will get some interest on this. 500 A1 will be equal to 500 plus 10% of 500. This is what you will get, right? So 500 plus 10% is 10 by 100 of 500. If I take out 500 common, what do I get? 1 plus 10 by 100, which is 0.1. This is what you get. At the 1 year, this is what you get. Basically, you multiply 500 by 1.1. Right? At the end of 1 year. At the end of 2 years, this 1.1 will be squared. At the end of 3 years, 1.1 will be cubed. At the end of 10 years, 1.1 raised to about 10 is what you will get. Right? That's question number 31 for us, and that's a complete explanation of this question. Question number 32 says, if AM and GM of roots of a quadratic equation are 8 and 5 respectively, okay, roots of a quadratic equation, let roots of quadratic equation are alpha and beta. Okay, arithmetic mean is 8. So alpha plus beta by 2 is equal to 8, and square root of alpha beta, this is a geometric mean, which is 5. This is given, right? Obtain the quadratic equation. Okay, if alpha and beta are the roots, quadratic equation, what does it look like? Quadratic equation looks like x square minus sum of the roots times x plus product of the roots equals 0. So this is something which we know. This is something that we know from our past experiences, right? From the concepts of quadratic equations. So we are only interested in those two values. Alpha plus beta is 16 from here, and alpha beta is 5 square, which is 25 from here. Therefore, equation will be x square minus alpha plus beta x, which is 16x, plus alpha beta, which is 25, equals 0. This is what you get. At max, what you can do is, okay, we want the roots, we can find the roots easily for this 25 and all. Okay, finding roots will be an issue. Will it be? You'll have to use quadratic formula maybe, because factorization will not take us anywhere, right? You'll have to use quadratic formula. But this is the quadratic equation which is required over here. Is that okay? Yes, that's the complete solution for this 32nd question, as you can see over here. And with this, we come to the conclusion of this particular long exercise based on geometric progression. In the next session, we'll be talking about another exercise from sequence and series, and some more interesting important concepts will be covered over there. Till then, all the best.